Activity sheet chapter number 14, substances in common use. First question, write the names of following salt, the formula of following salt, and name the acids and bases from which the salts are derived. Then comment about their pH. First is sodium chloride, and we know that the formula of sodium chloride is NaCl, and it is derived from base sodium hydroxide and acid hydrochloric acid, and both this acid and base, they are strong, hence the salt is neutral, and that's why its pH is 7. Second salt is sodium carbonate. Formula is Na2CO3, and we know that it is derived from a strong base sodium hydroxide and a weak acid carbonic acid. So strong base, weak acid, salt is basic and its pH is greater than 7. Then the next one, the salt is calcium carbonate. The formula is CaCO3. Again, it is derived from a strong base calcium hydroxide, weak acid carbonic acid, and again it's a basic salt, pH is greater than 7. Last one is ammonium chloride, NH4Cl, derived from a weak base ammonium hydroxide and a strong acid hydrochloric acid, and hence the salt is acidic in nature, and hence its pH is less than 7. So like that we can comment on the pH. Write the chemical formula of table salt. Chemical formula of table salt is NaCl. Name two salts which are formed using sodium chloride. The salts sodium bicarbonate and the other salt is sodium carbonate. So washing soda and baking soda, they are formed using sodium chloride. So answer is washing soda, which is Na2CO3.H2O, and other one is baking soda, which is NaHCO3. These are the salts which are formed using sodium chloride. Next question, write the chemical reaction. Electric current is passed through the solution of sodium chloride. Electric current is passed through brine. Brine is sodium chloride solution. So what happens in this reaction? Let us write down that reaction. NaCl aqueous, that means water solution is there, plus water H2O liquid, and when electric current is passed through this solution, this is called solution of brine. See, here are 4 ions present here, Na plus Cl minus, then we have H plus and OH minus. There is anode, there is cathode. Anode is positive charge, cathode is negative charge. So negatively charged ions are attracted towards the anode, and then the electron is taken away from the anion there, and chlorine gas is formed at anode. Similarly, Na plus and H plus, they go to cathode. Out of that hydrogen, it takes an electron from the cathode, and hydrogen gas is released at the cathode. So out of these 4 ions, H plus and Cl minus, they are turned into respective gases. So, and then what remains is NaOH, and that remains in the solution. So NaOH aqueous. So this is the total reaction. Then we have to balance it. There are 2 hydrogen, 2 chlorine are there, so we have to write 2 here. So 2 NaOH we have to write, and then for that 2H2O should be written here. So this is how the reaction takes place. Next question, which products are formed when electric current is passed through fused sodium chloride? Now this is a different reaction. This was aqueous solution of sodium chloride, that was called brine. And the second question they are asking us fused sodium chloride. So that means sodium chloride in liquid state. There is no water there. So when electric current is passed through fused sodium chloride, there are only two ions there, Na plus and Cl minus. So at the anode, as before, chlorine gas will be released, but at the cathode, instead of hydrogen in the previous example, we have sodium here, sodium in liquid state, chlorine in gaseous state. So we have to write 2 here and 2 here. So extraction of sodium. So this reaction, you can write it as extraction of sodium and this reaction, if you want to name it, it is called chlor-alkali process. There are two different reactions. This is chlor-alkali process, and then this reaction is extraction of sodium. Then what is rock salt, and state its use. So we have to salt obtained from certain type of rock is called rock salt. Mineral halite and Himalayan rock salt are some examples of rock salt. It is used to treat many diseases. So main constituent of this rock salt is NaCl only, but instead of deriving it from the sea, it is found in certain type of rocks. So that is rock salt. State the properties and uses of sodium bicarbonate, that is baking soda. The properties and uses of sodium bicarbonate. Sodium bicarbonate reacts with moist litmus paper and red litmus turns blue, and red litmus turns blue, and this is because sodium bicarbonate, as we have said before, is a salt of strong base NaOH and an weak acid carbonic acid, hence it's basic in nature, and being basic, it turns red litmus blue. It is used to make bread, cake and dhokla. Now when sodium bicarbonate is heated, it decomposes and gives us carbon dioxide gas. When it is heated, it gives us Na2CO3, that is sodium carbonate, and carbon dioxide gas along with water. If you write 2NaHCO3 here like this. So this carbon dioxide gas, it makes the edible substance soft and fluffy, and that's why it is used to make bread, cake and dhokla. Being basic in nature, it is used to treat acidity in the stomach. Then sodium bicarbonate is used to make active substance carbon dioxide, which is used in fire extinguisher, and the baking soda is also used to clean an oven. So the properties are, it is a basic salt. Applications are in making bread, cake and dhokla. Then is to cure acidity in the stomach. Then fire extinguisher, and in cleaning the oven. State the method of preparation of bleaching powder. Bleaching powder is made from slaked lime. When chlorine gas is treated with the slaked lime, a substance called calcium oxychloride CaOCl2 is formed, which we call it as bleaching powder. Give reason. Bleaching powder is used as a source of chlorine gas. Chlorine is inconvenient to handle because of its gaseous state. Also, it's a poisonous gas. Instead, solid bleaching powder has same effect and is more convenient to use. Bleaching powder undergoes slow decomposition due to carbon dioxide in air, and it releases chlorine gas. This is the chemical reaction which takes place. Bleaching powder plus the carbon dioxide gas in the air gives you chlorine gas, which is useful in disinfection and bleaching purpose. That's why bleaching powder is used as a source of chlorine gas. Write the chemical name of bleaching powder. Just now we said that bleaching powder is called calcium oxychloride. Calcium oxychloride. State the uses of bleaching powder. Write chemical equation. Bleaching powder reacts with dilute sulfuric acid. Properties and uses of bleaching powder we can summarize. Bleaching powder is a yellowish white solid substance. This is the first property. Yellowish white solid substance. Chemical name is calcium oxychloride. It has a strong odor of chlorine gas because it releases chlorine when it reacts with atmospheric carbon dioxide. So that process is spontaneous. So whenever bleaching powder is exposed to air, a chlorine gas is released in the air. It is used for disinfecting drinking water and disinfecting water in swimming pool. Uses for the bleaching of cloth. Use for the disinfection of roadside and garbage sites. Now, the chemical reaction that takes place. When this calcium oxychloride reacts with dilute sulfuric acid, chlorine gas is completely and rapidly taken away from the solution. So, we can write the chemical equation. CaOCl2 is the chemical formula of bleaching powder. When it reacts with dilute sulfuric acid, that is H2SO4, you can see that the calcium, it reacts with sulfate salt here and calcium sulfate is formed. Now this hydrogen and oxygen, they combine together to give you water, and finally the remaining component chlorine is. So it's a rapid reaction. Rapidly all the chlorine gas is extracted from the bleaching powder. Explain how washing soda can be used to soften the hard water. Now, this is a little bit longer answer. So, what is hard water? Basically, hard water is water which cannot form foam with the soap. So, hard water contains salts like calcium chloride, magnesium chloride, then calcium sulfate and magnesium sulfate. That means sulfates and chlorides of calcium and magnesium. So, these salts make water hard. So what happens when these salts, they react with soap? They form a white precipitate of calcium and magnesium carboxylate. And hence they cannot form foam. And that's why the water is called hard water. Now how this hard water is softened? The hard water is softened using the washing soda. Suppose we have to remove calcium chloride from the water. So when it is reacted with sodium carbonate, that is washing soda, what happens here is the exchange of ion takes place. That means here we have calcium cation chloride anion, then we have this sodium cation and carbonate anion. There is exchange of ions, so calcium reacts with this carbonate and sodium with this chlorine, and exchange of ions takes place, and the products of the reaction, calcium carbonate, which is actually insoluble in water, so it comes out of water as a precipitate, and soluble sodium chloride remains in the water. Hence you can see that the calcium ions are removed from the water. Similar reactions takes place with magnesium chloride, in which magnesium carbonate is produced, which is again insoluble in water. So these calcium magnesium ions, they are removed by this sodium carbonate, and after the removal of Ca2 plus and Mg2 plus ion, water is no longer a hard water, it can form foam with the soap. So this is how the washing soda can be used to soften the hard water. State uses and properties of washing soda. That is right. The properties and uses of washing soda. Washing soda is a whitish and odorless powder at room temperature. Litmus has blue color in the aqueous solution, that means it's a basic salt. Again the formula is Na2CO3, so it is made up of strong base, sodium hydroxide, weak acid, carbonic acid. So it's basic in nature. It's hygroscopic, that means it absorbs moisture if left exposed to air. Used mainly for washing clothes, as the name suggests, washing soda. Sodium carbonate is used in glass and paper industry, also in refining the petrol. Is used in glass and paper industry, refining of petrol. So you have to remember the properties. White powder, odorless. It is basic in nature. That's why it changes the red litmus blue. Then hygroscopic, that means absorbs moisture, absorbs water, vapor. Used for washing clothes in glass industry, paper industry, and refining of petrol. Then state some salts which contain water of crystallization. These are the examples of some salts which contain water of crystallization. In water of crystallization, water neither dissolves the salt into itself nor any chemical reaction takes place. In the crystal form of that salt, some of the water molecules are attached. For example, in case of alum, K2SO4, Al2SO4 thrice, 24 H2O, that means 24 water molecules are present. Alum is used in the process of water purification. It causes coagulation of solid impurities, and hence the water becomes clear if alum is added to it. Then we have the salt named borax, Na2B4O7 dot 10H2O, again example of water of crystallization. Epsom salt, that is magnesium sulfate, MgSO4 dot 7H2O. Barium chloride, BaCl2 dot 2H2O. Sodium sulfate, known as Glauber salt, Na2SO4 dot 10H2O. Blue vitriol, that is copper sulfate, CuSO4 dot 5H2O. This is called blue vitriol. Then this blue vitriol is used in the blood test for diagnosing anemia. In the Bordeaux mixture, which is used as fungicide on fruits like grapes, muskmelons, like lime, is used with blue vitriol. So application of blue vitriol for diagnosing anemia and as a fungicide on grapes, muskmelon, blue vitriol is used. State differences between the bathing soap and washing soap. The differences in bathing soap and washing soap. So let us write them in the tabular form. Both are soaps, that means both are the carboxylate salts of sodium or potassium. So first let us write bathing soap. And the next one is washing soap. The bathing soap contains potassium salt of fatty acid, carboxylic acid, that means potassium carboxylate, whereas washing soap is sodium salt of fatty acid. In the bathing soap, high quality fats are used, high grade fats and oils. Whereas in the washing soap you have low grade fats and oils. Then the bathing soap are not alkaline, whereas washing soaps are alkaline in nature for the strong action for cleaning the clothes. So these are the differences between the washing soaps and the bathing soap. Which substances are called radioactive substances? Elements with high atomic number such as uranium, thorium and radium have a property of spontaneously emitting invisible, highly penetrating, high energy radiation. This property of those elements to emit such radiations are called radioactivity, and a substance which are having these properties, they are called radioactive substances. Draw the diagram and experiment of alpha, beta, gamma rays. So you have to draw this diagram. So what is present in this diagram? We have a radioactive substance kept in a lead box. Then there is a small slit from which the radiations are passing. Then we have these electric plates having the positive and negative charge. You see that some of the rays, they are inclined towards the positive plate to a large extent. Then some rays are attracted towards the negative plate but to a lesser extent, and then some rays, they go without any deflection. The rays which are attracted towards the positive plate are called beta rays, and towards negative plate are called alpha rays, and the rays which do not deviate at all are called gamma rays. So this is the diagram that you have to draw. Complete the following table. The property, nature of alpha ray, they are helium nuclei, that means He 2 plus, having a mass of 4 units and having 2 plus positive charge. They are actually electrons, negatively charged particles with negligible mass, and the gamma rays are electromagnetic radiations, electromagnetic rays you can call them as. Then if you talk about the mass, they are having approximately 4 unified mass, then 1 upon 2000 unit, that means negligible mass, and the gamma rays, they are massless particles, so we can say that they have no mass. Then charge, alpha rays, they have +2 charge, beta rays -1 charge, and for gamma there is no charge on these particles. Then next one is velocity of alpha rays, they are 1/5 to 1/20th velocity of light. Then the beta rays 1/5 to 9/10th velocity of light, and the gamma rays, they actually move with velocity of light. Then the effect of electric field, alpha rays are attracted towards negative plate, beta rays are attracted towards positive plate, and for the gamma rays there is no deviation, as we have seen in the diagram. Next question is, state the uses of radioactive substances briefly in industrial field, agriculture and medical sciences. Applications of radioactive isotopes in the industrial field. For identifying the cracks and voids, we use cobalt 60, iridium 192. Measurement of thickness, density and level of aluminium, plastic and iron sheets. Thickness, density and level. Then luminescent plate means the paint which releases light even in the dark. In this krypton 85 is used, then promethium 147 is used, luminescent paint and radioluminescence. Luminescence means the light is given out. So these are the last one, using ceramic articles to decorate ceramic tiles, utensils, plates, etc. Earlier uranium oxide was used in these paints. Nowadays, due to this radioactive property, it is not used. So the 4 applications are there. The first is radioactivity, identifying the cracks and voids, cobalt and iridium 192. Measurement of thickness, density and level in the manufacture of aluminium, plastic and iron sheets. Luminescent paint and radioluminescence, krypton 85 and promethium 147 in the decoration of ceramic articles, utensils and plates. In the field of agriculture, radioactive substances are used for fast growth, higher productivity, etc. Genes and chromosomes are changed, so genetically modified crops, you can call it as GM crops. So in making GM crops, you can write to change the genetic properties of the seeds. Then the radioactive isotope cobalt 60 is used for food preservation. Onion potatoes are irradiated with gamma rays from cobalt 60 to prevent their sprouting, to avoid the sprouting for their storage. Strontium 90 is used as a tracer in the research of various crops. So agriculture field, there are 4 applications. One is the genetically modified crop, seed production, and they are made for fast growth, higher productivity, etc. Then cobalt 60 used for food preservation. Cobalt 60 to prevent sprouting of onions and potatoes. Strontium 90 used as a tracer in the research of various crops. Medical science applications include in the polycythemia, phosphorus 32 used in treatment. Polycythemia. To treat the bone cancer, strontium 89, strontium 90, samarium 153, radium 223 are used. Hyperthyroidism, iodine 123 is used to treat hyperthyroidism. Then for the tumor detection, boron 10, iodine 131 and cobalt 60 are used. Arsenic 74 is used for the detection of small tumors in the body. So polycythemia, phosphorus 32, bone cancer, strontium 89, strontium 90, samarium 153, radium 223, hyperthyroidism, iodine 123, and tumor detection, boron 10, iodine 131 and cobalt 60. State hazards caused by radioactive substances. Hazard caused by the radioactive substances, it affects the central nervous system. The radioactive radiations can affect central nervous system. Then defects, hereditary defects are generated by this exposure to the radiations. It can penetrate the skin, can cause skin cancer, leukemia. Radioactive pollutants created due to explosions enter body through air and it is difficult to control them. Radioactive pollutant released in seawater enter the bodies of fishes and through them they can enter human body. Radioactive paint on the watch can cause cancer. Radioactive isotope strontium 90 can enter the body through the plants, fruits, flowers, cereal, milk and cause diseases like bone cancer and leukemia. So these are the hazards caused by the radioactive substance. State the names of food items in which artificial colors are used. State harmful effects of artificial food colors. So the food items in which the artificial colors are used. The food colors in the form of powders, gels and pastes. They are used in ice creams, ice candies, sauce, fruit juice, cold drink, pickle, jam, jellies. They are also added to meat, chicken and mutton, chili powder, turmeric, sweets and other similar substances. So powders, gels and paste, artificial colors are used in ice creams, ice candies, sauce, fruit juice, cold drink, pickle, jam, jellies, mutton, chicken, chili powder, turmeric, sweets. What are the harmful effects of using the food colors? Food color added to pickle, jam, sauce contains small quantities of lead and mercury. Lead and mercury are harmful to those who consume this product on a regular basis. It can cause ADHD, that is attention deficit hyperactivity disorder. Can affect the children due to excessive consumption of food with added food colors. These are the hazards. Which natural dyes are famous in Kashmir? In Kashmir, saffron, the dye made up of saffron is famous. State adverse effect of dyes. Dyes are basically the colored substance which on applying to an article impart that color to the article. This is the definition of dye. Uses, they are used for coloring hair and clothes. Fluorescent colors are made street boards visible at night. Dyes are used to polish leather shoes, purses and chappal. Adverse effect, dyeing hair can have adverse effects like hair fall, then the damage to the hair texture, then burning of skin, adverse effect on eyes, etc. Lipstick contains a dye named caramine. It does not affect lips but can cause stomach disorders. Excessive use of plants for making natural dyes results in the deterioration of environment. Excessive use of plants. So these are some adverse effects: hair fall, skin burning, adverse effect on eyes, stomach disorder due to caramine. Then excessive use of natural dyes can result into the deterioration of environment. Then compare ordinary deo, anti-perspiring deo and clinical deo in a tabular form. State the harmful effects of deodorants. Ordinary deo contains smaller proportion of aluminium. Ordinary deo contains smaller proportion of aluminium. Anti-perspirant deo contains 15% of ammonium chlorohydrate, and clinical deo contains 20 to 25% aluminium. Ordinary deo is used to decrease the odor of the sweat. Anti-perspirant deo decreases extent of sweating, whereas clinical deo is used in case of people who sweat heavily. Harmful effects of the deo: aluminium zirconium compounds are most harmful. They can cause headache, asthma, respiratory disorder, heart disease. Then there is possibility of various skin disorders and also skin cancer due to ammonium chlorohydrates. So differences: ordinary deo contains lesser amount of aluminium. Anti-perspirant deo 15% of aluminium chlorohydrate, whereas clinical deo contains 20 to 25% aluminium. Ordinary deo decreases the odor of the sweat. Anti-perspirant deo clogs the sweat pores of the skin, decreases extent of sweating, whereas clinical deo used as night reduces sweating. Harmful effect causes means they are headache, asthma, respiratory disorders, heart disease. There is a possibility of various skin disorders, skin cancer due to aluminium chlorohydrates. Write chemical formula and chemical name of Teflon and state its uses. Teflon is its chemical name is polytetrafluoroethene. Polytetrafluoroethene. Its chemical formula is C2F4N. Uses of this Teflon. Teflon is a poor conductor of electricity, so it is used in cladded wires, then in electronic instrument as an insulator. For making non-stick kitchenware, the colored metal sheet of two-wheelers and four-wheelers are given a Teflon coating to protect them from the damage due to high temperature and rain. So Teflon, the atmosphere and chemical substances have no effect on Teflon. It is a non-stick material, nor oil nor water, neither water nor oil stick to that Teflon. No effect of temperature up to 327 degrees centigrade, and the articles are easy to clean. And these are the property and uses of Teflon. Insulator, non-stick kitchenware, then protection from high temperature and rain. No effect of atmosphere, chemical substances, then water and oil does not stick to it. Then it can sustain high temperature up to 327 degrees centigrade, and the articles made up of Teflon are easy to clean. Briefly explain the process of powder coating. Powder coating is a method of applying a layer harder than paint on the surface of iron object to prevent rusting. In this method, the raw materials like a polymer resin, a pigment and some other ingredient are melt mixed, cooled and ground to form uniform powder. Then this uniform powder is sprayed on the polished metal surface by the method of ESD, that is electrostatic spray deposition. So in this method, the electrostatic charge is given to the surface so that the powder sticks to the metal surface. Then the object is heated so that the polymerization takes place inside it, and the formation of long cross-linked polymeric chain, which is highly durable, hard and attractive, is formed. It is used for coating plastic and MDF board as well. So powder coating, it is a layer harder than paint. It prevents rusting. In this, a polymer, resin, a pigment and some other ingredient are melt mixed. That means they are heated, liquefied, then mixed, cooled, and then they are ground into a uniform powder. This powder is sprayed on the polished metal surface by means of electrostatic spray deposition method. Then in this, the article is given electrostatic charge so that these materials, the particles of the material, that is that resin and pigment, and it sticks to the metal surface. Then it is heated, in which cross-linked polymeric chains are formed. This powder coating can also be done on the plastic and MDF boards. In anodizing, which solution is used as electrolyte? Sulfuric acid, dilute sulfuric acid is used as electrolyte, which is selected as anode. Aluminium article to be anodized is used as anode. What is the advantage of the process? In this process, decomposition of water takes place and oxygen gas is produced at the anode. This oxygen gas reacts with aluminium to form a thick aluminium oxide layer on the aluminium article, which prevents the further corrosion of the surface. Last question. What is ceramic? State differences between porcelain and bone china. What are advanced ceramics? State their uses. A ceramic is a heat resistant substance formed by kneading inorganic substance in water and then shaping and hardening on heating. The difference between the porcelain and bone china: in case of porcelain, glass, granite and feldspar is mixed with kaolin kneaded with water. In case of bone china, some ash of animal bones is added to the mixture of china clay, feldspar and fine silica. This bone china is harder than porcelain. Advanced ceramics are made from the salts like alumina, Al2O3, zirconia, silica, and some other compounds like silicon carbide and the boron carbide. Uses of advanced ceramics. The advanced ceramics are used as superconductors. They are used to fix the outer layer of space shuttle. Then they are used for coating the interior of keen outer surface of ships and blades of jet engine. So ceramics first. What is a ceramic? A ceramic is a heat resistant substance formed by kneading an inorganic substance in water and then shaping and hardening by heating. Then porcelain contain glass, granite, feldspar, whereas bone china contain ash of animal bones along with the china, clay, feldspar and fine silica. Advanced ceramics have alumina, zirconia, silica, silicon carbide, boron carbide in them. They are used in coating the interior of keen outer surfaces of ships, blades of jet engines, etc.